Hi everyone. We're going to be looking at how to solve rational equations. So the general idea, when we're trying to solve a rational equation, we're going to multiply both sides of the equation by the lowest common denominator in order to eliminate fractions. Then we end up with, in our examples, we'll generally end up with a linear or a quadratic equation. In theory, you could end up with anything, but we're going to stick to linear and quadratic. And we have to pay attention to non-permissible values, as always, when we're dealing with algebraic fractions. Basic idea, though, real simple equation to start off with. If I don't want to have fractions anymore, then I need to identify the lowest common denominator of all the fractions. In this case, there is only one fraction, so the lowest common denominator is x. And then I'm going to multiply both sides of the equation by x. This accomplishes the simple goal of canceling out every denominator. So by using the lowest common denominator, I cancel everything. So in this case, the x's are gone. And I just end up with 4 equals x. Pretty straightforward in this case. There's nothing I need to do after this step. I double check it in the original equation. 4 divided by 4 equals 1. Yep. So there we go. 4 equals x. It can obviously get a little more complicated when we have more complicated things to start, but the same basic principle. Again, in this case, I only have one fraction, so my lowest common denominator just is the denominator of that fraction, x minus 1. So I am going to multiply both sides of this equation by x minus 1, which has the impact on the left-hand side of canceling out. X minus 1 cancels with x minus 1. On the right-hand side, I'll need to distribute. So I end up with x squared equals 4x minus 4. So this is a quadratic equation. So I bring everything over to one side so that it is equal to 0. I get a perfect square, actually. So this becomes x minus 2 times x minus 2 equals 0, which obviously if the product of two things equals 0, or you can think of it as x minus 2 squared equals 0, either way, x minus 2 has to equal 0, which means x equals 2. Here's where I have to be aware of non-permissible values. So looking back to my original, I get x can't equal 1. Well, x equals 2 is not a problem, so that is my solution. It's not a terrible idea to double check that in the original equation. So if I have 2 squared over 2 minus 1, well, that's 4 divided by 1, which is 4, which is what I wanted. So this works. Once I start having multiple fractions, then I am going to have to start dealing with the lowest common denominator. So if you want to pause and give these a try before you see how I work through them, by all means, go for it. In the first case, they're already factored. So I'm going to think of each of these numerators and denominators. I'm putting in brackets to remind myself these are individual factors. No part of them can be canceled unless all of them can be canceled. So my lowest common denominator is x plus 2 times x plus 3, just the product of these two denominators because there isn't anything in common between them, which means that I'm going to multiply both sides of this equation by that lowest common denominator. So we get x plus 2 times x plus 3 on the left, and x plus 2 times x plus 3 on the right. On the left-hand side, it's the x plus 2 that is going to cancel, leaving me with x plus 3 times x plus 1. So I get, x plus 3 times x plus 1 on the left-hand side. And on the right-hand side, it is the x plus 3 that is going to cancel, leaving me with x minus 3 times x plus 2. This is where it was kind of helpful to put those brackets at the beginning because now that reminds me that I need to distribute fully. So I get x squared plus 3x plus x plus 3 equals x squared minus 3x plus 2x minus 6. It looks like it's quadratic, but it actually isn't because as soon as I subtract x squared, it actually cancels on both sides of this equation. So when I just simplify, I get 4x plus 3 equals negative x minus 6. I'm going to move the negative x over to the left, which becomes now 5x, and I'm moving the 3 over. 5x equals negative 9. X equals negative 9/5. Double checking with my non-permissible values. I had x couldn't equal negative 2 and x can't equal negative 3. Well, negative 9/5 is neither negative 2 nor negative 3, so it seems that it's okay. It would be a good idea to plug that into your calculator and verify that what you get on the left-hand side when you substitute x equals negative 9/5 is what you get on the right-hand side. And if I plug those into my calculator, I do find, yes, it works. In practice, though, you really just need to verify that the answer you get is a permissible value. And in fact, we'll see in the next equation a case where that doesn't happen, where we do have to reject an answer. I'm going to comment a little further on this. I often get asked the question, well, aren't I just cross-multiplying? Sort of, except that cross-multiplication is not really a thing. It's not a mathematical operation. The reason cross-multiplication works is because you are effectively multiplying by the lowest common denominator. So from a mathematical standpoint, what cross-multiplication is multiplying by the lowest common denominator. And I prefer to think of it always as multiplying by the lowest common denominator, first off because it's more mathematically correct, but also because it is more generally applicable. So in this next example, I actually can't cross-multiply in this current form. So what I could do is I could combine the two fractions on the left into a single fraction using the techniques of adding together two rational expressions that we learned in our previous lesson. And then I could, well, I have a fraction equals a fraction, so then I can, in theory, cross-multiply. But I don't have to do those additional steps. I can do them just right from the very beginning, eliminate all the fractions, and only work with what will end up being a quadratic equation in this case, because I can multiply by the lowest common denominator of all three fractions. So cross-multiplication is essentially multiplying by the lowest common denominator in a very specific situation. Multiplying by the lowest common denominator is more general and will work for everything. So I'm going to start by factoring. The only one of these denominators that factors is the x squared minus 9, and it factors to x plus 3x minus 3, which conveniently are the other two denominators. So my lowest common denominator is x plus 3, x minus 3. Might as well at this stage also write out for myself that my non-permissible values are positive and negative 3. So I'm going to now multiply the left side of the equation, the whole thing, and the right side of the equation by this lowest common denominator. So x plus 3, x minus 3. On the right-hand side, that's easy. It's all just going to cancel, leaving me just with 18. So when I cancel out these two factors, on the left-hand side, or on the right-hand side, I just get 18. On the left-hand side, I'm having to distribute because there is an addition in the middle here. Right there, I've got an addition, which means that this multiplication by that lowest common denominator has to distribute. So when I distribute, in the first fraction, it's the x plus 3 that's going to cancel out. And in the second fraction, it's the x minus 3 that's going to cancel. So we end up with 2x times x minus 3, because the x plus 3 has canceled, plus x times x plus 3, because the x minus 3 cancels, equals 18, because on the right, the whole thing canceled. I distribute this out, and I get 2x squared minus 6x plus x squared plus 3x equals 18, which gives me 3x squared minus 3x minus 18 equals 0. The handy thing here, now it's quadratic, I want to factor, but I actually can just divide the whole equation by 3. And because, I could keep the 3 up front, so I could do it this way, x squared minus x minus 6 equals 0. Or I can actually just get rid of that 3 altogether, because I can divide by 3 on both sides of the equation, and 0 divided by 3 is still 0. It doesn't matter if I keep the 3 there or not, because ultimately it's not going to impact the answers I get. When I factor here, if I still had that 3 out front, 3 can't equal 0 because 3 isn't 0, so it doesn't really matter whether it's there or not. But I get two solutions to this quadratic equation, x equals 3 or x equals negative 2. However, I do have a non-permissible value that showed up here. So I have to cross that one out. It's not a solution to this equation. The reason it shows up is because if I were to plug 3 into this, I would get an error, a division by 0 on both sides of the equation. So basically, it's saying, look, this would be equivalent in this case, but we know that x cannot equal 3. So we are left with just x equals -2. If I were to try and plug these two values in, I would very quickly realize that 3 is just going to give me an error, a division by 0, but -2 does work. All right, and with this, we're actually going to also look at a word problem, a very classic type of word problem that we see with these rationals. It's one in which we have a speed, time, distance question. So these are based on the fact that the distance traveled is your velocity times your time. But in these types of questions, we're pretty much always going to work with them in the form time equals distance divided by velocity. So that the time it takes to travel somewhere is going to be the distance you need to travel divided by the speed at which you are traveling. So we have a bus traveling 480 kilometers. So the distance for the bus, so for the bus, I'm going to think about these three things. The bus, I know that the distance is 480 kilometers. The same amount of time, so time for the bus equals time for the car. The car has to travel, so dB for bus, dC for car, 570 kilometers. The speed of the car is 15 kilometers per hour faster than the speed of the bus. So let's call V bus, we'll just call it V, which means that the velocity of the car is going to be V plus 15. Now, I know that their times are the same, so I'm going to write an expression for each of them. Time for the bus, well, time is distance over velocity, so the bus has to go 480 kilometers, and it's traveling at an unknown velocity that I've called V. The time for the car, well, he has to travel 570 kilometers, and his velocity is being expressed with V plus 15. They are the same, so my equation is that they are equal. 480 over V equals 570 over V plus 15. This is now a rational equation. It has a lowest common denominator that is the product of these two denominators. So the lowest common denominator is V times V plus 15. My non-permissible values, if I think about this for a second, I get V can't equal 0. Well, obviously, the bus can't be going 0 kilometers per hour, or it would never travel 480 kilometers. And V can't equal -15. Well, obviously, again, because it's a velocity, it can't be negative. In fact, in this instance, I have the fact that what I know about the velocities is that they are greater than 0. So if I end up with any negative answers, I would have to reject them. But what I'm going to do now is I'm going to multiply both sides of this equation by V times V plus 15, which means that on the left-hand side, the V cancels. On the right-hand side, V plus 15 cancels. So what I end up with when I distribute, so V plus 15 times 480, I'm going to end up with 480 V plus 15 times 480, which is 7,200, so 7,200. And on the other side, 570V. When I subtract 570V minus the 480V to get them onto the same side, I get 90V equals 7,200, and I divide by 90, I get 80 equals V. That's not a non-permissible value. It does fall into a reasonable answer that I would expect for a speed. So V equals 80 kilometers per hour, which means that V plus 15 equals 90 kilometers per hour. So this is for the bus and this is for the car. We could verify these by actually doing the divisions to figure out if these are really the same time. So for example, if I say, okay, well, the time for the bus was 480 divided by now the number I know, which is 80, I get 6 hours. And if I do the time for the car, which was 570 kilometers, at what I wrote 90, but that's actually 95. So if I have 95 kilometers per hour and I divide 570 by 95, I get 6 again. And so that means that this works out. All right. Generally speaking, for these questions, you're going to be given distance and then some unknown for velocity, because that's really the best way to get them to turn into rational equations. And you'll be able to write them together into some equation based on information you know about the time. In theory, I could go a different direction. I could say, well, what if t was my unknown? And I could write an equation using the velocity relationship. And that would still work. If you're interested in seeing that, I actually will do that method of this exact same question in our live lesson on Thursday of this week. In the meantime, to practice rational equations, in your Precalculus 11 textbook, that's section 6.4, which together with the rational expressions and operations lesson finishes chapter 6. So once you've had a look at all of that, you can also be looking at the chapter 6 review. And as well, from our last unit, you had been given a worksheet on rational functions, equations, and inequalities. We had dealt with the rational functions stuff, but I told you that was only part of the worksheet. You can actually now go look at questions 11 through 15 on that same worksheet, and that covers rational equations.